Today we will start a new chapter, linear programming problem. In short, we will call this one as a LPP. That is a linear programming problem. In the final examination from this chapter, total 7 marks will cover. That is a 1 mark, 1 question, 6 marks, 1 question. That is a part A, you will get 1 question, and part E, in the E section, we have 2 parts, A part and B part. That is separated as a question as a 6 marks, A question as 6 marks, B question as 4 marks. So there in the part section, part E section, we have 2 questions. So in that 1 question, 1 part, we will get a linear question, a linear programming problem. Okay, very very important, and it is a easy chapter. Okay, so part A 1 question and part E 1 question. So definition, objective function. Before starting objective function, first we will come to know what is linear programming problem. Linear programming problem. What is linear? So we know that equation ax plus by plus c is equal to 0. It is a linear equation. It is a linear equation with 2 variables. Okay, here x and y are variables. Here x power is also 1, y power is also 1. So therefore it is a linear equation. As well as suppose ax plus b equal to 0. It is also a linear equation because the power of x is only 1. Okay, so therefore it is also a linear equation with 1 variable. Okay, so this is a basic definition of a linear. Okay, what is the objective function here? A linear function of the involved variables which we want to maximize or minimize subject to the given linear constraints. This is very very important. Linear constraints, okay, is called objective functions. Similarly, what is linear constraints? Then linear constraints, the limitations on the resources can often be expressed in the form of linear inequations. We know that in the first year, linear inequations. Okay, so linear equations is called linear constraints. Then for example, what is the objective function here? Which equation is called objective function? That is the linear function of the involved variables which we want to maximize or minimize here. For example, here maximize z equal to 3x plus 4y. This equation z equal to is called objective function. Objective function. Here z is called objective function because here we are going to find this maximized value or minimized value, minimum value of the function z. Okay, subject to constraints. Here we have inequalities, inequations, linear inequations, because here 2 variables are there, so 2 variable linear equation, and here we have inequations that is less than or equal to or greater than or equal to. This is a linear equation. If suppose this is the ax plus by plus c is less than or equal to 0, then we call this one as a linear inequation. Linear inequation. Okay, so therefore here less than or equal to is there and greater than or equal to is there. So therefore these two are linear inequations because x and y variable is also power is 1, variable's power is also 1. So therefore it is a linear inequation. Here z is called objective function and these are called constraints. These two are important for this function. And what is feasible region? Feasible region, the common region is determined by all the constraints. By using these two, we are going to plot the graph. In that common region, we will find out. Then, including non-negative constraints. What are non-negative constraints? Here, these two are called non-negative constraints. Or it is also x is greater than or equal to 0 or y is greater than or equal to 0. Okay. Of a linear programming problem is called feasible region. We will consider one example. Okay, first write it down. So consider one example. solve the following linear programming from graphically. Okay, here it is a graphically. Solve the following linear programming from graphically. Maximize z equal to 3x plus y subject to the constraints x plus y is less than or equal to 4, and also for all given x comma y is greater than or equal to 0. So let us consider given z equal to 3x plus 4y. It is a 4y. Okay, 3x plus 4y. We know that this is a objective function. Okay, it is a objective function, and also here it is a maximize. So therefore given is a maximize z equal to 3x plus 4y, which is our objective function, and also subject to constraints. Here we have only one equation in equations, that is x plus y is less than or equal to 4, and also given that x is also greater than or equal to 0, y is also greater than or equal to 0, which are non-negative constraints. For this one, first we have to consider the given in equation as equal. So x plus y equal to 4. Consider this one as x plus y equal to 4. Here first put x equal to 0. If x equal to 0, 0 plus y equal to 4, we get y equal to 4. Then the points are, I will consider this point as a, that is x equal to 0, y equal to 4. If suppose y equal to 0, put y equal to 0 in this equation. Okay, call this equation number 1. Then equation number 1 becomes x equal to 4. When x equal to y equal to 0, we get x plus 0 equal to 4, then x equal to 4. I will consider this point as a second point 4. This will be x equal to 4, y equal to 0. As we know that in the graph point, suppose consider P of x comma y. In the ordered pair, first coordinate is x pointer, second point is y. So therefore x equal to 0. Here in the first a pointer, x equal to 0. So therefore 0, y equal to 4, 4. In the second pointer, y equal to 0, but x equal to 4. So therefore 4 comma 0. Now we will plot this graph. So consider a graph x axis, y axis. Origin is 0, that is 0 comma 0. O origin is denoted by O 0 comma 0. Here in the x point we have maximum is 4. So therefore points are 1, 2, 3, 4. I consider 1 point extra 5. Here in the y coordinate is also 4 points. So therefore 1, 2, 3, 4. Consider 1 point extra 5. Now plot the points. Here first a point is 0 comma 4. When x equal to 0, y equal to 4. When x equal to 0, y equal to 4. This is a point. A of 0 comma 4. When x equal to 4, y equal to 0. When y equal to 0, x equal to 4. So this is a B pointer, that is 4 comma 0. Now join these 2 points. Join AB. Okay. Right? So now what we have to write here? So now plot the points. A point. We have 2 points here. So A is 0 comma 4 and B of 4 comma 0. B point is 4 comma 0. And next join AB. So here plotting the graph, pointer B and A join AB. Here our equation is x plus y is equal to 4. This is the line of x plus y equal to 4. Okay. And our equation is inequation. So therefore x plus y is less than or equal to 4. So less than or equal to 4. It means towards 0. The points are moving towards 0. That is here we have only one line. So therefore our region is less than or equal to 0. That is towards 0. If it is greater than or equal to 0, then moving far from the 0. Okay, towards the positive direction. Okay, so our region is we have to shade this part. This shaded portion is called visible region. This shaded region is called a visible region. What is our question? We have to maximize this objective function. Maximize z equal to 3x plus 4y. For that one, consider a point. Here in the graph we have three corner points. One is 0, 4. Second one is origin, and third one is B, that is 4, 0. So corner points. And we have to find the value of z equal to 3x plus 4y, corresponding values of the points. Okay, so we have 3 points. So first point origin I will consider 0, 0. Second point A of 0, 4. Third point B of 4, 0. Third point B is 4, 0. Put x equal to 0, y equal to 0 in this equation, because we have first point is 0, 0. That is x value is also 0, y value is also 0. So substitute x equal to 0 and y equal to 0, we get 0 only. Okay, because 3 into 0 is 0, plus 4 into 0 is 0, 0 plus 0 is also 0. Suppose put x equal to 0 and y equal to 4. If x equal to 0, this will become 0, plus y equal to 4, 4 into 4, 16. That is z equal to 16. Z equal to 16. What about the third one? Put x equal to 4 here, because x value is 4, y value is 0. We get z equal to 12. Now in these three points, z equal to 0, z equal to 16, z equal to 12, which is maximum? Which is maximum? Because here maximize. So we have to choose the maximum value of z. Here 16 is the maximum value. Maximum value. Okay, write it down. So therefore z is equal to 16. 16 is the maximum value. Now we have to write the conclusion part. Hence the maximum value of z, the maximum value of z is 16. Where? At the point A of A, at the point A, that is 0, 4. This completes the proof. Write it down.